Some nights the sky holds a kind of stillness that feels almost deliberate, as though the darkness above is not empty at all, but simply resting. If this feels like a good place to rest tonight, you're welcome to stay. Now let's drift. There is something the night sky has never shown you, not once. Not in any lifetime lived so far, and yet somewhere in the quiet architecture of the solar system it very nearly could have. Look up on almost any clear night anywhere, from a quiet street in Ohio to a hillside outside Lisbon, and the sky offers the same simple geometry it always has. A scattering of stars, a moon that changes shape slowly, patiently over about 29 days, and beyond that darkness, smooth and unbroken, stretching in every direction like a held breath. It is a sky that has looked this way for longer than any person has been alive to notice it, longer than any story has been told about it. Generations of eyes have traced that same emptiness, and generations of minds have quietly filled it with meaning. Researchers who study the history of the night sky often note that this simplicity is not an accident of imagination. It is real. Earth, unlike a handful of its neighbours, carries no ring around its middle, no faint band of light arching from horizon to horizon. There is only the moon, solitary, familiar, doing what it has always done. But scientists suggest that this was not always guaranteed. It seems that the space around a planet like Earth has at certain moments in its long history held more than empty orbit. Debris, fragments, small worlds that never quite finished becoming moons. To understand why it helps to sit for a moment with what a ring actually is, not as a shape but as a behaviour. A ring is not a solid object circling a planet the way people sometimes imagine it. It is closer to a slow, glittering crowd, countless small pieces of ice and rock, each one following its own quiet path, none of them touching for very long. Some are no larger than a grain of sand. Others could rest comfortably in the palm of a hand. A few rarer and more dramatic could rival the size of a small house, and all of them together move in a shared rhythm around their planet, held there not by any structure but by gravity alone, patient and invisible. It is a strange kind of harmony if you think about it slowly enough. Nothing is holding these fragments together. There is no thread, no shell, no boundary. And yet from a distance across the vast dark of space, they appear as one continuous shape, smooth and deliberate, like a single breath, drawn out over thousands of miles. The mind tends to do something similar with distant things. It gathers scattered pieces and quietly assembles them into a whole, a shape the eye can hold, even when the truth beneath it is far less orderly. Perhaps that is part of why rings, wherever they are found in this solar system, seem to draw such a particular kind of attention. They look deliberate, they look designed, and yet they are made of nothing more than motion and distance held in place by rules older than any planet that wears them. Earth does not wear one now. Its sky remains open plain, marked only by that single familiar moon. But the story of how a planet comes to have a ring, or comes to lose one, or comes so close to keeping one, that the difference is almost accidental, is a story that touches Earth more closely than it might first seem. There is a particular boundary in space, an invisible line, that exists around every planet where the pull of gravity becomes powerful enough to do something quite specific. It does not destroy in a violent or sudden way. It simply insists. It stretches. It pulls one side of an approaching object more strongly than the other, until whatever fragile shape that object once held can no longer hold itself together. Scientists are still exploring the exact mechanics of this boundary in different systems, but the underlying principle has been understood for a long time, now tested and confirmed again and again across the solar system. It's worth pausing here gently without rushing toward the details, because there is something almost tender about this idea. A boundary that does not destroy out of violence, but simply because closeness itself becomes too much to bear. A moon that drifts too near its planet does not explode. It comes undone slowly into pieces, the way a held breath eventually has to be released. And what remains afterward does not simply vanish. It stays. It orbits. It becomes something new, something flatter, quieter, more spread out than the moon it used to be. It becomes a ring. This is not only a distant idea told about far-off planets circled by ice and light. It is a pattern, a shape that space seems to return to again and again wherever the conditions allow for it. And it may be that Earth, across its very long history stretching back further than any human memory, brushed closer to this pattern than most people realize. None of this needs to be understood quickly. There is no test at the end of it, no need to hold every detail in place. It is simply a thread offered quietly, the kind of thing that can rest in the back of the mind while the body continues to settle breath by breath into something softer. For now, it is enough to know this. Somewhere in the neighborhood of our solar system, other planets do carry this shape. Bands of ice and stone circling patiently, catching starlight in a way Earth's sky never quite learned to do. And there is a particular kind of quiet in wondering what it might have looked like if things had gone only slightly differently. If that invisible line had been crossed just once. Long ago, in the early formless years when this planet was still deciding what kind of sky it would eventually keep. That thought can simply sit there for a while. No need to chase it any further tonight. The sky outside remains the same as it always has, dark and open and familiar. And somewhere just beneath that familiar darkness there is a much older story quietly waiting patient, as it has always been content to be found slowly at whatever pace feels comfortable. There is a particular kind of quiet that settles over a room once the mind has stopped reaching for anything new, and it is in that quiet that a thought can be allowed to simply continue, the way a stream continues past a bend without ever announcing that it has turned. So let it continue now softly back toward those distant bands of ice and stone. A ring seen from far enough away looks like a single object, smooth, continuous, pale line drawn carefully around a planet as though someone had traced its equator with a steady hand. But researchers have found that this smoothness is something of a gentle illusion, the kind the eye creates when it cannot quite resolve distance and detail at the same time. Up close, a ring is not one thing at all. It is an uncountable number of small things moving together, close enough to seem unified, far enough apart to remain technically alone. Each fragment within a ring follows its own orbit, its own quiet lane around the planet, obeying gravity in the same patient way a leaf obeys a current. Most of these fragments never touch their neighbours. They pass near one another, sometimes only a few feet apart, sometimes close enough that a person standing on one could reach toward the next and almost brush against it. And then they drift on, unhurried, carried by momentum and by the pull of the world they circle. It may be that this is part of what makes rings feel so different from almost anything else found in space. Planets are singular, moons are singular. But a ring is plural in a way few other things are, a structure made entirely of separateness and yet, from a distance, appearing as one continuous whole. There is something quietly familiar in that idea, if it is allowed to settle for a moment. A gathering of many small unconnected things, each moving along its own path, forming together something that looks from far enough away like a single steady shape. The composition of these fragments is in most cases studied so far surprisingly simple. Ice, mostly. Water ice, the same basic substance that gathers on a window in winter, except here it exists in countless small and drifting pieces, catching sunlight and scattering it outward in a soft, cool glow. Mixed among the ice are smaller amounts of rock and dust, dark fragments that quietly absorb light rather than reflect it, giving many rings a faint layered texture, brighter in some places, dimmer in others, like light falling unevenly across a snowy field at dusk. What we understand so far suggests that this mixture of ice and rock did not arrive already assembled. It gathered slowly collected by gravity over long stretches of time, the way sediment settles quietly to the bottom of still water. Some of it may have come from a moon that drifted too close to its planet, pulled apart by the same gentle, insistent force described earlier. Some of it may simply be material left over from the very early formation of a planetary system debris that never finished becoming anything larger content instead, to remain small, plentiful, and endlessly orbiting. There is a certain peace in that thought if it is given room to breathe. Not everything in space is required to become something grand. Some material simply continues unfinished, unhurried, existing quietly in its own gentle rhythm. One detail tends to surprise people the first time they hear it, and it is worth sitting with for a moment because it reshapes how a ring is often imagined. Despite stretching across distances that can span tens of thousands of miles from edge to edge, a planetary ring is in most known cases remarkably thin. Not thin in the way a sheet of paper is thin, but thin in a way that is almost difficult to hold in the mind. If a large ring system were shrunk down to the width of a football field, its actual thickness, according to the scale researchers often use to describe it, would be thinner than a single human hair laid across that same field. It seems that this thinness is not a flaw or a coincidence, but a natural outcome of gravity's steady influence over time. Particles that drift slightly above or below the main orbital plane are gradually pulled back into alignment, nudged gently into the same flat patient formation as everything around them. Given enough time, scattered material tends to settle the way anything left long enough. In stillness tends to find its own quiet level. There is something almost tender in imagining that kind of settling. A vast chaotic beginning full of tumbling ice and drifting stone slowly softening over millions of years into something flat, orderly and calm. Not because anything forced it to be so, but simply because time given enough patience tends to smooth what it touches. The particles themselves are rarely still even within their shared flattened plane. They collide gently and often brushing against neighbouring fragments in soft repeated contact that barely disturbs their path. Scientists suggest that these frequent low-speed collisions are part of what keeps a ring system so remarkably flat and so evenly distributed. Each small collision transfers a little momentum, nudging wandering fragments back toward the average path of the group, the way a gentle current might slowly guide a scattering of leaves back into a single drifting line. It is a strange kind of order built entirely from repetition rather than instruction. No fragment knows where it is supposed to go, and yet through countless small quiet interactions the whole system arranges itself into something coherent. The mind tends to notice patterns like this even outside of astronomy. A gathering of small, individually unremarkable moments repeated often enough, slowly shaping something whole and recognizable. Habits form this way, so in a much quieter sense does rest. Not all rings are the same width or brightness, and evidence suggests that this variation comes largely from differences in the size and density of the particles within them. Where ice is more abundant, a ring tends to appear brighter, reflecting sunlight in the wide glowing bands. Where rock and dust dominate, the same ring can seem to fade into faint shadowed gaps, almost invisible against the darkness behind it. From certain angles, entire ring systems can appear to vanish altogether, their lighter lines so precisely edge-on to a distant observer that only the faintest sliver remains visible, a reminder of how much of what exists in space depends entirely on the angle from which it happens to be seen. There is a soft parallel in that one that does not need to be stated too directly. So much of how something appears depends on where a person happens to be standing when they look at it. Between the icy fragments, faint gaps sometimes appear thin corridors of near emptiness cutting cleanly through an otherwise dense ring. Researchers have found that these gaps are rarely accidental. Often a small moon, sometimes no larger than a mountain, orbits quietly within or near the gap. its gravity clearing a narrow path through the surrounding debris the way a slow current might carve a clean channel through drifting sediment. These small moons are sometimes called shepherd moons, guiding the edges of a ring simply by existing nearby, without any effort beyond their own quiet gravitational pull. It is a gentle kind of influence worth pausing on. Not force, not control, just presence, steady and continuous, gradually shaping the space around it simply by being there. None of this movement is especially fast, at least not in the way the word fast is often imagined. A fragment drifting through the outer reaches of a ring system may take many hours, sometimes longer, to complete a single orbit around its planet. Everything here moves according to a much slower clock than the one carried by daily human life, a rhythm shaped by gravity, distance and time, working together over spans that stretch far beyond a single lifetime. The brain tends to interpret vast timescales like this with some difficulty, since so much of daily thought is built around minutes and hours rather than millions of years. But it may be that some quiet part of the mind still recognizes this kind of patience, even without fully grasping the numbers behind it. A process unfolding slowly, without urgency, without rush, simply continuing because continuing is what it does. That kind of patience does not ask to be understood all at once. It only asks to be allowed to continue, and it will gently in a moment. There is a particular boundary that was mentioned earlier, only in passing the way a door might be mentioned, before anyone has actually stepped through it. It deserves a slower look now because it holds one of the more delicate truths about how a planet and its companions relate to one another across the quiet distance of space. In the year 1848, a French astronomer named Édouard Roche sat with a fairly simple question and worked it through with careful mathematics. He wanted to know how close a moon could come to its planet before something changed. Not before it crashed, not before it burned, but before the planet's own gravity became too uneven across the moon's small body to be survived in its current shape. What he found still carries his name today quietly in textbooks and observatories alike. It is called the Roche limit, and it describes something almost tender about closeness. The idea that even gravity patient and invisible as it is, can eventually ask too much of something small. To understand it gently, it helps to imagine two sides of the same object. A moon orbiting a planet is pulled by gravity, of course, but not evenly. The side of the moon facing the planet feels a slightly stronger pull than the side facing away, simply because it is closer. Ordinarily, this difference is small enough to be harmless, absorbed quietly into the moon's own structure. But researchers have found that as a moon drifts nearer to its planet, that difference grows and grows, until the pull on the near side becomes so much stronger than the pull on the far side that the moon can no longer hold itself together as one continuous shape. It does not happen suddenly the way a struck glass shatters. It happens more like a slow unravelling, a quiet coming apart piece by piece, the way a loosely tied bundle might slip open if carried too far without ever being properly bound. What is left afterward does not disappear. It simply spreads. The fragments continue orbiting, now scattered rather than joined, following paths very close to the one their moon once followed, until over time they settle into the flat, patient shape that was described earlier. A ring, in other words, may very often be the quiet aftermath of a moon that came too close. There is something almost gentle in that idea, even though it involves a kind of ending. Nothing is destroyed in the way destruction is usually imagined. Something simply changes form, spreading outward instead of holding inward, continuing to exist just differently than before. The Roche limit is not the same distance for every moon, and studies indicate that this depends heavily on what the moon itself is made of. A moon built from solid, dense rock can survive much closer to its planet than a moon made from looser material ice mixed loosely with dust held together more by gentle accumulation than by true structural strength. It is in a way a question of how tightly something is holding itself together before it is asked to withstand an uneven pull. Some real moons in this solar system exist unsettlingly close to that boundary right now, and it seems that their futures are already in a slow and unhurried sense decided. Triton, the largest moon orbiting Neptune, moves on a path that is gradually tightening, drawing closer to its planet with each long, patient orbit. Scientists are still exploring the exact timeline, but the general shape of the outcome is fairly well understood. Many millions of years from now, Triton will likely cross its own Roche limit, and Neptune, which currently wears only a faint, dim collection of thin rings, may eventually gain something far more dramatic in their place. Mars offers a smaller, closer example. Its moon Phobos sits nearer to its planet than almost any other moon in the solar system sits to its own, and researchers have found that it is spiraling inward slowly year by year, in a descent too gradual to notice within a single human lifetime, yet steady enough to measure with careful instruments. It may be that in some tens of millions of years, Phobos will meet its own Roche limit, and Mars, currently ringless, may briefly wear a faint band of dust and stone before that material eventually settles onto the planet's red surface entirely. There is a certain quiet comfort in numbers like these, strange as that may sound. Tens of millions of years, a timescale so vast it stops feeling like counting at all and starts to feel more like simply trusting that some things continue unresolved long after any single observer could witness their ending. Saturn itself, whose rings have already been described in some detail, likely owes its most famous feature to this very process, repeated perhaps more than once across its long history. What we understand so far suggests that its current ring system may be relatively young in astronomical terms, possibly only a few 100 million years old, rather than as ancient as the planet itself, hinting that a moon, or perhaps several, met their Roche limit somewhere in Saturn's more recent past, leaving behind the wide glowing bands now studied so closely from Earth. It raises a soft, almost wondering question, one that does not need to be answered tonight. If Saturn's rings are this recent in a cosmic sense, then the sky above Saturn, if such a sky could be observed by anything, would have looked different, plainer, for a very long stretch of its own history, only becoming what it is now after that quiet unravelling took place. The mind quietly registers ideas like this differently than it registers ordinary facts, not as something to memorise, but as something closer to a shift in scale, a reminder that the universe is still very much in the process of becoming whatever it is going to be. One slow moon, one slow orbit, one slow boundary crossed at a time. Earth, for what it is worth, has no moon currently drifting toward its own Roche limit. The moon that circles this planet now is, if anything, moving gently away a few centimetres further each year, drawn outward rather than inward by the same tidal forces described earlier, only working now in the opposite direction. But long before this current moon existed, in the earliest, most unformed chapters of Earth's history, conditions were different. Debris was more plentiful. Orbits were less settled. And it may be that somewhere in that early chaos something did cross that invisible boundary, briefly, quietly leaving behind a story too old and too faint for any direct evidence to fully confirm. That thought does not need to be chased any further than this. It can simply be allowed to rest here unfinished, the way so many things from that early period of any planet's life remain gently unresolved, waiting patiently for better instruments, or perhaps for nothing at all. There is a quieter layer to this one that most people never consider resting just beneath the physics of moons and boundaries and slow patient decay, and it has less to do with what happens to a moon and more to do with what a planet's sky might actually look like once that quiet unravelling is complete. Somewhere in the story of any object in the sky, there is a first person who looked and did not quite understand what they were seeing, and Saturn's rings begin in a very real sense with exactly that kind of confusion. In the year 1610, an Italian astronomer named Galileo Galilei pointed one of the earliest telescopes ever built towards Saturn, expecting perhaps to see something like a slightly larger version of what he had already observed around Jupiter. Instead, he found something strange. Saturn appeared to have two smaller bodies pressed closely against either side of it. Motionless companions that did not behave like any moon he had studied before. He wrote in his own private notes that Saturn seemed to have ears. The instruments of the time were simply not refined enough to resolve what he was actually looking at. And for years afterward, the strange shape remained an open question quietly unresolved. It took another 45 years and a considerably improved telescope for the truth to become clear. A Dutch astronomer named Christian Huygens, observing Saturn in the year 1655, proposed something that must have felt at the time almost imaginative. He suggested that Saturn was surrounded by a thin, flat ring entirely detached from the planet's surface, encircling it without ever touching it. Researchers today regard this as one of the more elegant early insights in the history of astronomy, not because the tools were advanced, but because the idea itself required a kind of patient, careful looking that resisted the urge to explain the strange shape too quickly. There is something quietly moving in that history, if it is allowed to settle for a moment. Two people working decades apart, both looking at the exact same planet, and only slowly, gently arriving at what was actually there. 20 years after Huygens made his proposal, an Italian astronomer named Giovanni Cassini noticed something further. Looking closely at Saturn's ring, he identified a thin, dark gap running through it, a narrow space where the light seemed to fade almost to nothing before returning again on the other side. This gap now carries his name, the Cassini division, and it remains one of the more visible features of Saturn's ring system, even through a modestly sized telescope today. What we understand so far suggests that gaps like this one are not empty in any absolute sense, but rather areas where orbital forces, often shaped by nearby moons, have cleared away much of the surrounding material, leaving behind something closer to a quiet corridor than a true void. For a very long time afterwards, Saturn's rings remained something studied only from a great distance, a pale glowing band observed through glass and patience imagined more than truly seen. That changed rather dramatically in the final decades of the 20th century. In the early 1980s, two spacecraft named Voyager passed close enough to Saturn to send back images unlike anything available before. For the first time, the rings were visible not as a single smooth band, but as an intricate structure made of thousands of individual ringlets, some wide, some impossibly thin, nested closely together like grooves pressed into vinyl. Scientists suggest that this level of fine structure surprised even those who had spent their careers studying the planet, revealing a system far more detailed and dynamic than earlier observations had ever suggested. But it was a later mission, simply named Cassini, after the same astronomer who had identified that dark gap centuries earlier, that offered the closest and most patient look Saturn's rings have ever received. Launched in the late 1990s and arriving at Saturn in 2004, the Cassini spacecraft spent 13 years quietly orbiting the planet, passing near the rings again and again, gathering images and data with a kind of persistence that feels almost gentle in itself. 13 years of watching the same rings shift subtly, with the planet's seasons catching sunlight at different angles, revealing details that a single brief visit could never have captured. One of the more curious discoveries to come from this long observation involves something researchers now refer to as spokes, faint dark wedge-shaped markings that occasionally appear across sections of the rings, only to fade again within a matter of hours. It seems that these spokes are connected to fine dust-sized particles that become temporarily charged, lifted slightly above the ring's usual plane, by forces not yet fully understood. Scientists are still exploring exactly why they form when they do, and why they sometimes appear in clusters, only to vanish just as quietly as they arrived. There is something hinting in the fact that even after centuries of careful study, Saturn's rings still hold small mysteries like this, quiet enough to remain mostly unnoticed, patient enough to still be waiting for a clearer answer. The temperature within the rings themselves tends to surprise people when they hear it for the first time. Despite their icy composition, and despite existing so far from the warmth of the sun, the rings are not uniformly extremely cold in the way distant space is often imagined. Studies indicate that temperatures across the ring system vary considerably depending on a particle's exposure to sunlight, ranging from relatively milder conditions on sunlit surfaces to far colder temperatures on shadowed sides, sometimes within the very same small fragment of ice. Each tiny particle in its own quiet way experiences something like day and night warmth and cold simply by rotating slowly as it orbits. There is a soft kind of company in that image if it is allowed to rest for a moment. Countless small fragments, each one turning gently through light and shadow, each one experiencing its own brief private version of a day out there in the wide quiet dark. Toward the end of its long mission in 2017, the Cassini spacecraft was deliberately guided on a final gradual descent, passing repeatedly through the narrow gap between Saturn's innermost rings and the planet's upper atmosphere, closer than any spacecraft had dared to fly before. During these final passes, instruments detected something researchers had long suspected, but never directly measured: a slow continuous rain of fine icy material falling from the rings down into Saturn's atmosphere. It may be that this quiet infall has been happening for a very long time, the rings slowly imperceptibly feeding themselves into the planet they surround, one small fragment at a time. Neuroscientists have observed that endings like this, slow and largely invisible, tend to be processed by the mind quite differently than sudden ones. There is little for the brain to fix upon, no clear before and after, only a long, continuous fading that resists being neatly summarized. Saturn's rings, in that sense, are not simply sitting still in the sky. They are very gradually, very patiently coming to an end, so slowly that the process itself becomes almost indistinguishable from permanence. None of this needs to feel heavy. It is simply another layer of the same quiet motion described earlier, another reminder that even something as vast and luminous as a ring system exists inside its own long, unhurried timeline, continuing for now, changing so gradually that an entire human lifetime could pass beneath it without ever noticing the difference. For now, the rings remain wide and pale and endlessly turning exactly as they have appeared to every patient observer since that first confused glance through Galileo's small telescope all those centuries ago. And somewhere in that long, unbroken thread of careful, curious looking, there is a quieter question still waiting, gentle and unresolved, about what a sky like that might actually feel like from underneath. There is a particular kind of imagining that scientists allow themselves from time to time carefully, without ever losing sight of what is real and what is simply useful to picture. It is not guessing exactly, and it is not fantasy either. It sits somewhere quieter in the space between known physics and open curiosity, and it is exactly the kind of thinking that applies here to a question that has likely crossed more than a few minds while looking up on a clear night. What would it actually look like if Earth still had its ring today? To imagine this properly, it helps to return briefly to what has already been described, that quiet, invisible boundary discovered by Edouard Roche. The point at which a moon drifting too close to its planet begins to come apart rather than continue whole. Earth's moon, as mentioned earlier, is moving gently outward, not inward, drifting a few centimeters further away each year. But researchers who study planetary formation have long considered a different question, one that does not depend on the current moon at all. What if in Earth's very early history, before this moon existed in its current form, some other body, smaller, looser, less structurally sound, had crossed that boundary instead? It is not an idle question. Evidence suggests that Earth's history includes at least one enormous formative collision, the impact that many researchers believe led to the moon's original formation, when a body roughly the size of Mars struck the young Earth and sent a vast quantity of debris into orbit. Most of that debris eventually gathered together to form the moon itself. But it may be that not all of it did. Some fraction, some scattered remainder could plausibly have remained in orbit a while longer, unassembled, drifting in a wide, loose band, before eventually settling, falling inward or dispersing entirely. If some version of that debris had instead settled into a stable ring close enough to Earth to remain visible far enough to avoid falling immediately, the sky above every person alive today would look entirely different than it does now. Picture it slowly the way a memory is sometimes pieced together, rather than recalled all at once. Instead of a plain open darkness scattered only with stars, the sky would carry a wide pale arc stretching from one horizon to the other, passing directly overhead for anyone standing near the equator. Researchers who have modelled hypothetical ring systems around Earth suggest that depending on the ring's distance and composition, it would appear far brighter than anything currently in the night sky, apart from the moon itself, a broad glowing band rather than a single point of light. From most of North America and Europe, that band would not pass directly overhead, but would instead arc lower closer to the horizon, tilted according to Earth's own axial lean. It would rise in the evening, not as something new, but as something continuous already present, simply becoming visible as the sun's light faded enough to reveal it. Unlike the moon, which changes shape and sometimes disappears from the sky entirely for a few nights each month, a ring like this would remain constant present every single night in roughly the same position, shifting only slightly with the seasons. There is something quietly different in that consistency worth sitting with for a moment. The moon offers a kind of gentle unpredictability, waxing and waning, occasionally absent altogether. A ring would offer something else entirely, a permanent presence, patient and unchanging, always exactly where it was the night before. The brightness of such a ring would depend heavily on what it was made of, and studies modelling similar systems suggest a wide range of possibilities. An ice-rich ring, similar in composition to Saturn's, would reflect sunlight strongly, potentially bright enough to be easily visible, even through the glow of a city's artificial lighting. A pale band cutting across the sky above traffic lights and illuminated windows alike. A ring composed more heavily of rock and dust would appear dimmer, more subtle, closer to the faint soft haze of the Milky Way, as it is sometimes glimpsed from a dark countryside sky present, but requiring a quieter kind of looking to notice. It seems that either version would have shaped human experience of the night sky in ways that are difficult to fully separate from culture itself. Every early calendar, every ancient method of marking the passage of seasons tends to rely on visible repeating patterns in the sky. A ring appearing at a slightly different angle depending on the time of year would have offered another such pattern, another quiet clock hanging above every early civilization alongside the sun, the moon and the stars. One especially interesting detail hinted at in earlier discoveries about how a ring behaves becomes particularly relevant here. Rings viewed edge-on, as mentioned before, can appear to nearly vanish, their light reduced to only the faintest visible sliver. If Earth's hypothetical ring existed at an angle tilted relative to its orbit around the Sun in a manner similar to how Saturn's rings are tilted relative to its own orbit, then the ring's visibility from Earth's surface would shift gradually across the year. Researchers modelling this kind of scenario suggest it might grow wide and prominent during certain seasons only to thin dramatically during others, sometimes nearly disappearing before slowly widening again as Earth continued along its orbit. There is a certain poetry in that idea, even though emerges entirely from geometry rather than any intention. A sky that changes not only with the day and the month, but with a much slower yearly rhythm, widening and narrowing, the way breath widens and narrows, a chest patient and cyclical, tied to nothing more than the quiet mechanics of orbit and angle. The ring's colour would likely shift as well, depending on the angle of sunlight striking it. Near sunrise and sunset, when sunlight travels through more of Earth's atmosphere before reaching the ring, the reflected light might carry warmer tones, soft ambers and pale golds similar to the way clouds sometimes catch the last light of day. Later in the night, with the sun's light striking more directly, the ring might shift toward a cooler, paler white closer to moonlight in tone, though considerably broader in shape. It may be that a sky like this would have altered something quieter than culture and calendars, something closer to the felt experience of nighttime itself. Psychologists often note that darkness plays a meaningful role in how humans regulate rest, signaling the body towards slower, quieter states as light fades. A wide reflective ring, even a relatively faint one, would have softened that darkness somewhat, never allowing true, absolute blackness to settle over the land, replacing it instead with a dim, ambient glow present in every clear night regardless of the moon's own phase. Whether this would have made sleep easier or more difficult is not something current research can answer with any certainty, and it would likely have depended heavily on the ring's actual brightness, something that remains ultimately speculative. But it is a gentle thing to imagine a version of night that was never fully dark, softened instead by a constant distant light hanging quietly overhead, the way certain memories hang quietly at the edge of thought, always present, rarely examined too closely. None of this changes the sky that actually exists tonight, plain and open and marked only by that single familiar moon. But it may be that some quiet trace of this imagined version lingers anyway, in the shape of old questions and older wondering, the kind that has apparently occurred to more than one careful mind across the years, curious about a version of Earth that came close in its earliest and least remembered years to keeping something Saturn never let go of. There is another layer to this imagining one that moves beyond simply what the sky would look like and settles instead on the ground itself, on what such a ring would actually do to the land beneath it, quiet, season after season, in a way that might be the most vivid part of this whole thought to picture. The shape of a shadow rarely gets much attention, at least not compared to the light that creates it. But shadows carry their own quiet information, and nowhere is that more visible than in the one true ringed planet already studied so closely throughout this journey. Saturn, it turns out, does not just wear its rings, it is shaded by them. Researchers working with data gathered during Cassini's long mission noticed something particular about Saturn's upper atmosphere, something that unfolds slowly over the course of the planet's own extended seasons. Saturn takes nearly 30 Earth years to complete a single orbit around the Sun, and because its rings are tilted relative to that orbit, the shadow they cast onto the planet shifts gradually across that long cycle, widening during certain seasons, narrowing during others, sometimes falling across the northern hemisphere, sometimes the southerns, depending on where Saturn happens to be along its slow path. Instruments studying the temperature of Saturn's cloud tops found measurable cooling in the specific bands lying beneath the ring's shadow, a difference of several degrees between shaded and sunlit latitudes, a signature written directly into the planet's own atmosphere by the rings hanging above it. There is something quietly remarkable in that. A ring is not simply decoration hanging weightlessly in the sky for anyone to admire. It changes the world beneath it gently, continuously, shaping, temperature and light in patterns that shift with the seasons, season after season, for as long as the ring continues to exist. This is the layer of the story worth spending real time inside tonight, because if Earth had kept its own ring, this shadow would not remain a distant abstract idea. It would fall quite literally across fields and coastlines and cities across the same ground where ordinary daily life continues to unfold. To picture this properly, it helps to return to the ring's geometry described earlier, tilted at an angle relative to Earth's orbit, much the way Saturn's own rings are tilted relative to its path around the Sun. As Earth continued through its yearly orbit, the angle at which sunlight struck that ring would shift gradually, and so would the position of the shadow it cast. During certain months, the shadow might fall mostly across higher latitudes, a wide, dim band settling over northern Europe or southern South America, while equatorial regions remained largely untouched, bathed in ordinary uninterrupted daylight. During other months, as Earth moved further along its orbit, that same shadow might drift toward the equator instead, leaving the higher latitudes in comparatively brighter, more consistent light. It seems that this shifting would create something Earth has never actually experienced in its long climatic history, a second much slower layer of seasonal change moving independently of the familiar cycle created by Earth's axial tilt. The usual seasons, the ones shaping temperature and daylight, now would continue as they always have, but layered on top of them, patient and gradual, would be this second rhythm, the ring's shadow drifting slowly across the surface of the planet, arriving in certain regions for weeks or months at a time, before slowly withdrawing again. Picture a single afternoon beneath that shadow somewhere in a temperate region during the appropriate season. The sun would still rise as it always does, climbing steadily toward its highest point. But partway through the day, as the ring's shadow crossed overhead, the light would dim, not suddenly the way a passing cloud dims a field, but gradually, evenly, the way a room slowly darkens as evening approaches, except that this darkening might arrive at midday, uninvited by any clock, then just as gradually lift again as the shadow continued its slow crossing. Scientists modelling similar hypothetical scenarios suggest that the effect would likely resemble a very deep, very extended version of the dimming that occurs during a partial solar eclipse, though considerably gentler and far longer lasting, stretching across hours or even days at certain latitudes rather than the brief minutes an eclipse typically offers. There would be no sudden darkness, no dramatic drop in temperature, only a slow softening of daylight arriving quietly and departing just as quietly like breath, drawn out longer than expected before finally being released. The temperature effects, based on what has already been observed at Saturn, would likely follow a similarly gentle pattern. Regions lying beneath the ring's shadow for extended periods might experience measurably cooler average conditions during that stretch of the year, while regions outside the shadow's reach remained comparatively warmer, creating a kind of secondary climate pattern layered quietly across the more familiar one, already shaped by latitude and season. Evidence from Saturn's own atmosphere suggests these differences need not be dramatic to be measurable, sometimes only a handful of degrees, but consistent enough to leave a discernible signature in long-term data. It may be that entire ecosystems adapted over countless generations would come to anticipate this second rhythm, the same way so much of Earth's existing life has adapted to anticipate ordinary seasonal change. Migration patterns, flowering cycles, the timing of animal breeding, all of it shaped in the real world by cues of light and temperature, might have developed some quiet relationship with the ring's shadow as well, an additional variable folded gently into rhythms already practiced by wind, tide, and sun. There is a certain grace in imagining life adjusting itself to something this vast without any apparent effort. The way roots grow toward water without ever being taught, to the way certain flowers turn slowly across the day to follow a light they cannot see with anything resembling an eye. Adaptation rarely announces itself. It simply happens quietly, generation after generation, until whatever pattern once seemed strange becomes simply how things are. The visual experience of standing beneath such a shadow, based on how ring shadows are described appearing on Saturn's cloud tops, would likely be soft rather than sharp. Unlike the crisp, dark edge of an object blocking direct light, a ring's shadow tends to have gentle, gradual boundaries, since the ring itself is made of countless small separated particles rather than one solid mass. Sunlight would not simply switch off at the shadow's edge. It would dim, slowly fade, gradually, then just as gradually brighten again on the other side, more like the soft gradient of dusk than the sudden line of an eclipse's edge. Someone standing outside during this transition might notice only that the quality of light had changed, grown a little cooler in tone, a little dimmer in intensity, the way light shifts subtly when thin clouds pass high overhead without ever fully obscuring the sun. Shadows on the ground would soften slightly, lose some of their sharpness the way shadows always soften under diffuse rather than direct lighting. It might feel in a way that is difficult to describe, precisely like standing inside a very large room where someone somewhere had just turned the lights down slightly without any clear source for the change. Psychologists often note that humans respond to gradual shifts in light very differently than they respond to sudden ones. Sudden darkness tends to trigger alertness, an old reflexive response tied to unpredictability and caution. Gradual dimming, by contrast, tends to be processed by the brain in a much calmer way, closer to the way dusk is experienced now, a signal not of danger but of transition, something to settle into rather than react against. It seems entirely possible that a slow-moving ring shadow arriving gently over the course of a day would register in the body less like an alarm and more like an invitation to slow down, an atmospheric cue towards stillness rather than urgency. There is something quietly beautiful in that possibility, worth letting rest in the mind for a moment. A shadow vast enough to stretch across entire countries and yet gentle enough in its arrival that it might simply feel like an unusually soft afternoon, unremarkable in the way that only truly enormous things sometimes manage to be. The colour of that shadow, based on modelling done for hypothetical ring systems, would likely carry a subtle tint depending on the ring's composition, a faint blue-grey where ice dominated the ring's structure, or a warmer, dustier tone where rock and fine particles made up more of its mass. Photographers and painters in this imagined version of Earth might have spent generations trying to capture that particular quality of light, the way artists throughout actual human history have spent generations trying to capture the specific gold of late afternoon sun, or the particular blue that settles just before true darkness falls. It raises a soft, unhurried question about how deeply light itself shapes memory and meaning, how something as simple as the colour of an ordinary afternoon can become, over enough repetition, something closer to identity, a quality of home too subtle to explain to someone who has never stood beneath it. None of this shadow exists today, of course. Earth's sky remains open, evenly lit, marked only by the sun's steady singular light and the moon's familiar changing glow. But there is a quieter layer to this one that most people never consider resting just beneath the physics of light and shadow already described, and it has less to do with what falls across the land during the day, and more to do with what such a ring might do to the darkness that follows once the sun has gone down entirely. Darkness, real darkness, the kind that used to settle fully over a landscape once the sun disappeared, is becoming something of a rarity on Earth today. Researchers who study nighttime environments have found that a significant portion of the world's population now lives under skies affected by artificial light skies that never quite reach the deep, uninterrupted black that once defined every night before electricity existed. But long before street lights and glowing windows changed the character of night, and in the hypothetical version of Earth being explored throughout this journey, there was another factor that might have softened true darkness in an entirely different, much older way. A ring, as described earlier, reflects sunlight even after the sun itself has dropped below the horizon. This is not unlike how the moon behaves now, borrowing its light rather than producing it, catching the sun's rays even while the sky around it has gone fully dark. But where the moon offers a single, relatively small source of reflected light, a wide ring stretching across a significant portion of the sky could offer something considerably more diffuse and continuous, a broad, gentle glow, rather than one concentrated point. Scientists modelling similar hypothetical ring systems suggest that depending on the ring's brightness and its position relative to an observer, nighttime illumination on a ringed Earth could be measurably higher than what is experienced under a typical moonless sky today. Not bright enough to resemble daylight, not even close to that, but bright enough to soften the deepest black of night into something closer to a persistent low twilight present in every clear night, regardless of whether the moon happened to be full, new, or somewhere in between. There is something worth sitting with in that idea gently without rushing past it. An entire planet that never quite experiences absolute darkness. Not because of anything built or invented, but simply because of what happens to hang quietly and permanently in its sky. This kind of persistent, gentle nighttime light already exists briefly at very high latitudes on Earth today, though, for very different reasons. During certain summer months, regions near the Arctic Circle experience what is often called civil twilight throughout the entire night, a soft, lingering glow along the horizon that never fully fades to complete darkness before the sun begins to rise again. People living in these regions during these months often describe a particular kind of restlessness, a sense that the body is uncertain what time it actually is, uncertain when to fully settle into sleep. It may be that a ringed Earth, if the ring were bright enough, could have introduced a milder, more widespread version of that same experience, not confined to a single season or a narrow band of latitude, but present in some gentle form across much of the planet every night throughout the year. Neuroscientists have observed that human sleep depends heavily on darkness as a biological signal, specifically through its influence on a hormone called melatonin. In the presence of light, particularly light containing certain wavelengths associated with daytime sun, the body's production of melatonin remains suppressed, keeping a person feeling more alert. As darkness deepens, melatonin levels typically begin rising, gradually preparing the body for rest. This is part of why exposure to bright screens or artificial lighting late at night can make falling asleep more difficult now, since that light interferes with the natural signal darkness would otherwise provide. If Earth's nights had never grown fully dark to begin with due to the constant ambient glow of an overhead ring, it seems entirely possible that human biology itself might have adapted differently across the long span of evolutionary time. Perhaps melatonin production would have evolved to respond to a dimmer threshold of darkness, one calibrated not to true black but to whatever level of dimness a ringed sky reliably provided each night. Researchers who study evolutionary adaptation often note that biological systems tend to calibrate themselves to whatever conditions remain consistent across many generations, rather than to some fixed universal standard. A species evolving under a permanently softened night might simply develop a different baseline for what darkness and therefore rest actually means. There is something quietly comforting in that thought if it is allowed to settle for a moment. Perhaps sleep itself is less about reaching some fixed absolute condition, and more about reaching whatever specific rhythm a body has learned over countless generations to trust. Beyond human experience, an ever-present ring light would likely have shaped the behavior of nocturnal animals in noticeable ways. Many species that hunt or move primarily at night rely heavily on very low light conditions to remain hidden from predators, or conversely to detect prey more easily under near total darkness. Studies of animal behavior under varying moonlight conditions today already show measurable shifts. Some nocturnal predators become more active during darker moonless phases, taking advantage of reduced visibility, while certain prey species become more cautious during brighter, fuller moon phases when they are more easily seen. A permanent ring-driven ambient glow present every night rather than cycling through phases like the moon might have pushed these already sensitive behavioral patterns in an entirely different direction. It may be that nocturnal life on a ringed Earth would have adapted to a sky that never offered the deep cover of true darkness at all, developing instead around a world where some degree of visibility was simply the permanent, unavoidable condition of every single night. There is a certain elegance in imagining a whole category of life adjusting itself so thoroughly to a single unchanging feature of its environment, the way desert life adapts to unrelenting heat or deep sea life adapts to unrelenting pressure, each ecosystem quietly organizing itself around whatever constant it happens to be given. Even certain plants might have been affected, since some flowering and growth cycles are known to respond to subtle variations in nighttime light exposure, a phenomenon researchers refer to as photoperiodism. Studies indicate that many plants use the length and intensity of uninterrupted darkness as a cue for when to flower, when to shed leaves, or when to prepare for dormancy ahead of colder seasons. A world where true uninterrupted darkness rarely if ever occurred might have required these internal plant calendars to calibrate themselves quite differently, responding perhaps to more subtle gradations of dimness rather than to one clear, consistent threshold of black. None of this changes what Earth's actual nights are like now, dark in the way they have always been, apart from the more recent and very different influence of artificial light. But it offers a gentle, unhurried way of imagining just how deeply something as vast and distant as a ring could reach down through ecosystems, down through evolutionary time, down into the very hormones responsible for something as simple and as necessary as falling asleep. There is a soft parallel worth noticing here, one that connects this imagined ringed world back to something entirely real. Even without any ring at all, Earth's actual moon already exerts a small measurable influence on human sleep. Some studies have found subtle changes in sleep patterns around the full moon, when nights grow naturally brighter, hinting that even a modest shift in ambient light is enough to gently nudge something as fundamental as rest. It seems that the body has always been listening to the sky in ways that rarely rise to conscious attention, adjusting itself quietly night after night to whatever light happens to be present overhead. That listening does not require a ring to exist. It has been happening all along, patient and largely unnoticed, in the quiet relationship between a sleeping body and whatever soft light manages to reach it through the dark. Nothing in space, it turns out, is built to last forever. Not even something as vast and luminous as a ring stretched across tens of thousands of miles. Beneath the quiet beauty already described, there is a slower, steadier process at work, one that has been shaping the fate of every ring system since the moment it first formed. Rings, patient as they seem, are always very gradually coming apart. Researchers studying Saturn's rings have identified several separate processes working together, each one slow, each one nearly invisible across any single human lifetime, yet each one steadily nudging the entire system toward its eventual end. The most direct of these involves something already touched on briefly, that quiet infall of icy material detected during the Cassini spacecraft's final approach, material drawn gradually downward by Saturn's own gravity raining slowly into the planet's upper atmosphere. What we understand so far suggests that this process, sometimes called ring rain, is happening more quickly than earlier estimates once assumed. Instruments aboard Cassini measured the rate at which charged icy particles were falling from the rings into Saturn's atmosphere, and the resulting calculation suggested a surprisingly brisk timeline, at least by the patient standards of planetary science. Rather than persisting for billions of years, Saturn's current rings may last only a few 100 million years more before this steady rainfall thins them beyond recognition. There is something quietly humbling in a number like that. A few 100 million years sounds at first impossibly long, far beyond anything the human mind is built to hold with any real intuition. And yet set against the age of Saturn itself, a planet that has existed for more than 4.5 billion years, a few 100 million years suddenly feels almost brief, a passing chapter rather than a permanent feature. It seems that Saturn spent most of its long history without the rings it is now so widely known for, and it may spend a comparable stretch of future time without them. Again, the rings themselves existing only as a relatively short luminous interval within a much longer, quieter story. The infall of icy material is not the only force working against a ring's permanence. A second, quieter process involves simple erosion, the slow grinding effect of countless small collisions occurring continuously between ring particles. Scientists suggest that even in a system as spacious as a planetary ring, fragments are packed closely enough that gentle collisions happen constantly, chipping away small amounts of material with each contact, the way waves slowly smooth the edges of stones along a shoreline. Not through any single dramatic impact, but through endless patient repetition. Over sufficiently long timescales, this constant low-speed grinding gradually reduces larger fragments into smaller ones and smaller fragments into fine dust. That dust, lighter and more easily influenced by outside forces, becomes increasingly vulnerable to drifting away, entirely pulled outward by the faint but persistent pressure of sunlight itself, a phenomenon researchers refer to as radiation pressure. It seems delicate to imagine sunlight alone possessing enough force to slowly push material out of orbit, yet studies confirm that across long enough timescales, this faint pressure meaningfully contributes to the gradual thinning of fine ring material. There is a certain tenderness in picturing that kind of erosion, so different from anything resembling destruction. Nothing shatters, nothing collides violently. It is simply countless small gentle touches repeated across millions of years, slowly wearing something vast down into something smaller, the way patience itself sometimes wears down even the sharpest edges of grief or worry, not through force, but through sheer quiet repetition. Solar radiation affects rings in another way as well, one connected to something called the Poynting-Robertson effect, a subtle drag created as sunlight interacts with small orbiting particles, gradually causing them to lose a tiny amount of orbital energy over time. Researchers have found that this effect is most significant for very small particles, the kind of fine dust already produced by all that patient collisional grinding. Bit by bit, this drag causes fine material to spiral gradually inward, drawing it closer to the planet until it eventually either falls into the atmosphere or crosses paths with denser sections of the ring and becomes absorbed there instead. Saturn is not alone in facing this slow unraveling. Every known ring system in the solar system appears to be governed by these same basic processes, meaning that rings, wherever they are found, exist as temporary structures rather than permanent features sustained for a time, then gradually consumed by the very forces that helped create them in the first place. Uranus offers a particularly interesting case since its rings are notably darker and less icy than Saturn's, composed largely of material that reflects far less sunlight. Scientists are still exploring why Uranus's rings differ so significantly in composition, though it may be that their darker material simply erodes and depletes through a somewhat different balance of these same underlying processes, aging in its own particular way, shaped by whatever specific mixture of ice, rock and dust happened to gather there. Neptune's faint thin rings appear to be in an even more advanced stage of this same slow decline, sparse enough in places that some sections seem to fade almost entirely from view existing more as faint arcs than as complete continuous bands. Researchers studying Neptune's ring system suggest it may represent something close to a late-stage snapshot of what ring decay eventually looks like, a preview, in a sense, of the kind of thinning and fading that even Saturn's currently bright and prominent rings will likely experience someday. There is something quietly moving in the idea that these different ring systems scattered across different planets might actually represent different chapters of the very same story, rather than entirely separate phenomena. Saturn, bright and relatively young in ring terms, sits near one end of that story. Neptune, faint and heavily eroded, sits much closer to the other, and somewhere between them, invisible but implied, lies the whole long, patient arc, connecting a freshly formed ring to whatever quiet, scattered remnant eventually remains. It raises a soft, unhurried question about permanence itself, one that does not require any particular answer tonight. So much of what appears fixed and eternal, especially across a single human lifetime, is in truth simply moving very, very slowly toward its own eventual change. A ring feels timeless while it exists the way a familiar landscape or a long-standing routine can feel permanent simply because it has remained the same for as long as a person has been alive to notice it. And yet nothing observed so far in these systems remains entirely still. Everything continues quietly transforming according to its own long, unhurried clock. None of this needs to feel like an ending in any dramatic sense. It is simply another expression of the same patient motion that has run through every part of this story so far, the same slow settling, the same gradual change, the same quiet continuation that shapes so much of what exists in the wider universe. A ring does not need to last forever to be real or to be worth this kind of careful attention. It only needs to exist for as long as it exists, luminous and patient, before settling gently into whatever comes next. And somewhere in that long, slow arc of decay and change, there is a much older question still waiting quietly about what a ring like this might have meant to anyone who once looked up and found it there night after night, long before understanding anything about Roche limits or radiation pressure at all. Long before telescopes, long before anyone understood what a ring was actually made of human beings, still looked up at the sky and quietly built entire worlds of meaning out of whatever patterns they found there. This is worth sitting with for a while, not as history exactly, but as a kind of gentle mirror held up to that earlier imagined version of Earth, one still wearing its wide, pale ring across every clear night sky. Anthropologists who study early human relationships with the sky often note that nearly every ancient culture, regardless of geography or era, developed some system for tracking celestial patterns, not out of idle curiosity but out of necessity. The position of the sun marked planting seasons. The phases of the moon marked the passage of shorter cycles, weeks and months, measured out by a shape that grew faded and grew again. Stars fixed in their slow-wheeling patterns across the year offered navigation orientation, a way of knowing where one stood both literally and in a much older, more spiritual sense. It seems reasonable to imagine that a ring wide and constant and slowly shifting with the seasons in the way already described earlier would have become one of the most significant of these patterns, arguably more prominent than most stars, more consistently present than the moon's changing phases. What we understand about how early civilizations related to fixed celestial features suggests that something this visible, this unchanging in its basic presence, would very likely have become central to how time itself was measured and understood. Consider for a moment how differently a calendar might have developed under such a sky. Earth's actual early calendars were built primarily around the moon and the sun, tracking months through lunar phases and years through the sun's changing path. A ring, however, tilted at its own particular angle, and slowly shifting brightness or width across each yearly orbit, would have offered an entirely separate, much slower marker, a way of tracking not weeks or months, but the turning of entire seasons, wide and gradual, arriving and receding like breath. Researchers who study the archaeoastronomy of ancient monument structures like Stonehenge in England or the Great Pyramids of ancient Egypt have found that many of these sites appear deliberately aligned with specific solar or lunar events, sunrise on the solstice, moonrise at particular points in its cycle. It may be that on a ringed Earth, similar monuments would have been built instead to track the ring's own slow widening and narrowing stone corridors, and carefully placed markers designed to frame the moment each year, when the ring reached its widest, brightest arc across the sky, or the quieter moment when it thinned nearly to invisibility. There is something deeply moving in imagining that kind of architecture structures built not around fear or power, but around simple, patient observation. An entire culture's understanding of time folded quietly into stone, aligned with a rhythm too vast and slow-glow for any single lifetime to witness more than a handful of times. Mythology, too, would likely have taken a shape around such a feature, the way mythology across actual human history has always gathered around whatever the sky most consistently offered. Historians who study comparative mythology often note certain recurring themes across unrelated cultures: a great river in the sky, a bridge connecting the world of the living to the world of the dead, a road walked nightly by ancestors or spirits. Many of these myths, researchers suggest, likely originated from human attempts to explain the faint pale band of the Milky Way visible on sufficiently dark nights, even without any ring at all. If a much brighter, much more prominent ring had existed instead, hanging closer and reflecting far more light than the faint haze of the galaxy's own arm, it seems likely that mythologies across very different, unconnected cultures might have converged on remarkably similar interpretations: a bridge, a river, a road, a boundary between one realm and another, written not into the vague haze of distant starlight, but into something bold, continuous, and undeniably present every single night. Psychologists who study how humans respond to consistent environmental patterns note that the brain tends to treat unchanging, reliable features of its surroundings very differently than it treats variable or unpredictable ones. Reliable, constant patterns tend to fade quietly into the background of conscious attention over time, becoming less something actively noticed and more something deeply unconsciously trusted. The way the sound of a familiar home settles into silence after enough years spent living inside it. A ring present unfailingly every clear night across countless human generations might have become exactly this kind of quiet background trust, not something marvelled at nightly by every individual, but something so foundational to the felt experience of night that its absence, if it were ever somehow removed, would likely have felt deeply disorientingly wrong. There is a tender kind of thought hidden inside that idea. Some things become most deeply loved not through moments of intense attention, but through sheer patient consistency, simply by remaining present night after night until their presence becomes indistinguishable from safety itself. Some evidence from Earth's actual history offers a small real echo of this kind of relationship between sky and psychology. Researchers studying indigenous astronomical traditions across various cultures, from Polynesian navigators reading star patterns to guide long ocean voyages to certain African and Aboriginal Australian communities tracking subtle seasonal changes through the sky's darker regions rather than its brighter ones, have found that human beings are remarkably attuned to even very subtle celestial patterns, capable of building extraordinarily precise systems of knowledge around whatever consistent signals the sky happens to offer. It may be that human perception itself has always been quietly shaped by whatever pattern happened to be available, adapting its attention generation after generation to notice and eventually depend on whatever the sky consistently provided. This raises a soft, unhurried thought worth carrying gently forward. Perhaps the specific shape of the sky, matters less in the end than the fact that human minds have always found some pattern to hold on to within it, some fixed point of reference against which time, meaning, and belonging could be quietly measured. A ring would have offered one such pattern. The moon and stars as they actually exist offer another. In either case, the underlying human tendency remains the same, a quiet, persistent reaching toward whatever the sky offers, and a slow, patient weaving of that pattern into culture, memory, and myth. It seems fitting then that even now, under the actual sky that exists without any ring at all, people still look upward instinctively during moments of difficulty or wonder, still find some quiet comfort in starlight, still measure the passage of significant nights, anniversaries, solstices, the first clear sky, after a long stretch of clouds by what they see when they simply tilt their heads back and look up. That instinct did not require a ring to develop. It seems to be something older, something that would have found its pattern in whatever sky happened to exist. Ring or non-star or shadow, always searching quietly for something steady enough to hold on to. The mind, it seems, has been keeping something still and patient all along, a quiet capacity for finding meaning in repetition, for turning whatever pattern the sky provides into something worth remembering, something worth building an entire understanding of time around. And that same quiet capacity, it turns out, extends far beyond myth and memory alone, reaching all the way down into the body itself, into the slow, steady rhythms that govern rest and hunger, and the simple, necessary act of sleep. There is a particular event that happens once a year along certain stretches of coastline near Australia's Great Barrier Reef, quiet beneath the surface of the water, easy to miss, unless someone happens to be looking at exactly the right moment on exactly the right night. Marine biologists who study coral reproduction have documented something remarkable. A mass spawning event in which numerous coral species release their eggs and sperm into the water simultaneously, all within the same narrow window of time, sometimes just a single hour across many square miles of reef. What makes this synchronization possible has fascinated researchers for decades, and the answer, when it finally emerged, turned out to be beautifully simple. Coral spawning is timed closely to the lunar cycle, occurring reliably several nights after a full moon, when moonlight begins to wane just slightly from its peak brightness. Studies indicate that certain light-sensitive proteins within coral tissue respond directly to the intensity and timing of moonlight, functioning almost like a biological calendar embedded within the organism itself, coordinating an event that depends entirely on getting the timing exactly right across countless individual coral colonies at once. There is something quietly extraordinary in that idea. An organism with no eyes, no brain in any conventional sense, no ability to consciously observe the sky, and yet capable of responding with such precision to a light source hundreds of thousands of miles away. It suggests that the relationship between living things and the sky above them runs far deeper than conscious awareness, reaching down into biology itself, into mechanisms far older than any nervous system. If Earth carried a ring bright enough to noticeably alter nighttime illumination as described earlier in this journey, it seems reasonable to wonder whether such deeply light-sensitive processes might have developed quite differently. Researchers who study photoperiodism in marine organisms suggest that a permanently altered baseline of nighttime brightness, rather than the moon's familiar waxing and waning, could have required coral and similar organisms to calibrate their reproductive timing around an entirely different signal. Perhaps the ring's own slow seasonal shifts in width and brightness, rather than the shorter monthly rhythm the moon currently provides. This same deep sensitivity to lunar or ambient light extends well beyond coral reefs. Certain species of moths researchers have found use the moon as a navigational reference point, maintaining a constant angle relative to its position to fly in a straight line during long-distance travel. Artificial lights unfortunately sometimes interfere with this ancient system, drawing moths into disoriented spiraling patterns as they mistake a nearby lamp for the distant reliable moon. Scientists studying this phenomenon note that it reveals just how deeply certain navigational instincts are tied to very specific, very ancient assumptions about how light in the night sky behaves, assumptions built up over evolutionary timescales far longer than any human civilization. It may be that under a ringed sky, offering a much broader, more diffuse source of ambient light rather than a single distant point, these same navigational instincts in flying insects would have needed to develop along entirely different principles, perhaps relying less on a fixed point of reference, and more on the overall gradient of brightness across the horizon, since a wide ring rather than a single small moon would not offer quite the same kind of precise directional landmark. Migratory birds offer another compelling piece of this larger pattern. Ornithologists have found that many species rely on a combination of cues to navigate vast distances during seasonal migration, including the position of stars, the planet's magnetic field, and notably changes in day length that signal when it is time to begin their journey. This day-length sensitivity, known as photoperiodism in animals just as it exists in plants, triggers hormonal changes that prepare a bird's body for the physical demands of long-distance flight weeks or even months before the migration actually begins. Researchers studying this hormonal trigger have found that it is remarkably precise, responding to changes of only a few minutes in daily light exposure, gradually accumulating across many days until a clear seasonal threshold is crossed. It seems entirely possible that on a ringed Earth, where a portion of nighttime darkness was consistently softened by ring light, this delicate seasonal signal might have needed to develop a different sensitivity altogether, tuned instead to the more complex combination of daylight length and the ring's own gradually shifting brightness, layering two seasonal signals together, rather than relying on daylight alone. There is a certain grace in imagining biology adapting to complexity this way, layering pattern upon pattern, never simplifying, simply finding new and increasingly intricate ways to stay synchronized with whatever the sky consistently provides. Predator and prey relationships too would likely have shifted under such conditions. Wildlife researchers studying nocturnal ecosystems today have documented a phenomenon sometimes called the lunar phobia effect, where certain small prey animals, various species of rodents in particular, reduce their nighttime activity noticeably during brighter, fuller moon phases, likely as a defense against being more easily spotted by predators relying on visual hunting. Conversely, some predators, including certain owl species, show increased hunting success during these same brighter nights when their prey's cover is somewhat diminished by the additional light. A permanently brighter nighttime environment sustained not by a monthly cycle, but by a constant ever-present ring, could have fundamentally altered this delicate balance. It may be that prey species under such conditions would have evolved toward greater overall caution, having never experienced the deep, reliable darkness that currently offers safety during the moon's darker phases. Alternatively, researchers modelling such hypothetical ecosystems suggest that some prey species might instead have shifted their most vulnerable activities, feeding, travelling, seeking mates toward whichever portion of the year the ring's own shadow or angle happened to offer the dimmest available conditions, adapting not to daily lunar cycles, but to the ring's own slower seasonal rhythm instead. This layered complexity extends quietly back to human biology as well. Returning to a thread mentioned earlier in this journey, sleep researchers studying modern human populations, particularly those living in areas with minimal artificial light exposure, have found subtle but measurable changes in sleep patterns tied to the lunar cycle, changes in the time it takes to fall asleep, in the overall depth and duration of sleep achieved even in populations completely unaware of the moon's current phase. It seems that human biology retains at least a faint echo of the same deep light sensitivity found throughout the rest of the animal kingdom. A quiet, largely unconscious responsiveness to ambient nighttime brightness that persists even now, in a world filled with artificial lighting that likely masks much of this effect entirely. If a ring had existed throughout human evolutionary history offering that same kind of persistent, gentle nighttime glow described earlier, it may be that this subtle biological sensitivity would have developed into something considerably more pronounced, an internal rhythm, calibrated not to a roughly monthly lunar cycle, but to the ring's own broader seasonal shifts in brightness, layering yet another gentle rhythm into the body's already complex internal clock. There is something deeply calming in recognizing just how many living systems, from coral, with no eyes at all, to migrating birds crossing entire continents, to a sleeping human body registering the faint difference of a full moon, without any conscious awareness at all, remain quietly continuously attuned to whatever light the sky happens to offer. It suggests that this kind of listening patient and largely unconscious might be one of the oldest and most universal relationships shared across nearly all of life on Earth, a relationship that would likely have continued simply adjusted to a different rhythm under a sky that looked entirely different than the one that actually exists. None of this requires a ring to be true right now. The moon alone, quiet and familiar as it has always been, continues to reach gently into fields, forests, coral reefs and sleeping bodies alike. A small patient reminder that the sky above has never truly been separate from the life unfolding beneath it. No matter how distant or how simple that connection might at first glance seem to be, there is a particular kind of vastness that becomes easier to hold once it is broken down into something small enough to imagine clearly, and perhaps nothing does that quite as gently as looking outward beyond this solar system, entirely toward other stars and the strange distant worlds that circle them. For a very long time, everything described so far in this journey belonged only to the planets orbiting one particular star. Saturn, Uranus, Neptune, and the hypothetical version of Earth explored earlier, all of it confined to a single familiar solar system. But astronomers have in more recent years begun finding hints that ring systems may not be quite so rare across the wider universe, that this particular shape, this particular pattern of ice and dust, circling patiently around a central body, might be something the universe returns to again and again, far beyond the boundaries of any single star's small family of planets. One of the more remarkable examples researchers have identified involves an object named Chariklo, a small body orbiting far out in the solar system beyond Saturn, classified as a centaur, a term used for icy bodies that behave somewhat like a cross between an asteroid and a comet. In the year 2014, astronomers observed something unexpected while watching Chariklo pass in front of a distant star, a brief dimming pattern that suggested the presence of not one but two thin, distinct rings surrounding this small, unassuming body. It seems that Chariklo, despite being only a few hundred miles across, considerably smaller than any of the ringed planets already discussed, still manages to hold on to a delicate orbiting system of ice and rock, proving that a ring does not require a truly massive planet to exist. Even something small and quiet tumbling through the distant reaches of space can carry its own faint halo. There is something rather moving in that discovery worth letting settle for a moment. Grandeur, it turns out, is not a requirement for this particular kind of beauty. Even a small, mostly forgotten body far from the warmth of any sun can still hold something as delicate and improbable as a ring. Beyond this solar system entirely, astronomers have turned their attention to a distant star system containing a young planet, or possibly a very large moon, known by the designation J1407b, located far beyond anything visible to the naked eye. Researchers studying this system observed an extraordinarily long, complex dimming event as this object passed in front of its host star. a pattern of light interruptions so intricate that it strongly suggested the presence of a truly massive ring system. One scientist's estimate could be tens of times larger in diameter than Saturn's own rings, vast enough that if placed around Saturn itself, the rings would appear large enough in Earth's night sky to be easily visible even during daylight. It may be difficult to hold an image like that clearly in mind. A ring system so large it dwarfs anything found in the actual solar system, circling a planet that likely does not even fully qualify as a planet in the traditional sense. And yet the underlying physics researchers suggest appears strikingly similar to everything already discussed: gravity distance, the same delicate Roche limit boundary described earlier, simply operating at a considerably larger and more distant scale. There is a certain comfort hidden in that similarity, quiet and easy to overlook. The same basic rules, the same patient mechanics of gravity and orbit appear to govern ring systems no matter where they are found in the universe, whether circling a small icy body barely large enough to be named, or a colossal distant planet whose true nature remains only partly understood. It suggests a kind of underlying consistency running through the universe, the same soft, dependable physics quietly repeating itself across distances too vast to properly imagine. Astronomers are still exploring just how common ring systems might actually be among the countless exoplanets discovered so far, and current instruments remain limited in their ability to detect features this subtle around worlds so distant. It seems entirely possible that many more ringed worlds exist than have been confirmed hidden, simply because the necessary observational conditions, a planet passing precisely in front of its star at exactly the right angle, occur so rarely and briefly that most ring systems likely remain undetected, quietly circling their distant planets unseen and unrecorded for now. There is something gently humbling in that thought. So much of what exists in this universe likely remains simply unnoticed, not because it lacks beauty or significance, but because human instruments, however advanced, have not yet happened to be looking in exactly the right place at exactly the right moment. This idea connects in a quiet way back to something much closer to home, back to the very personal, very human experience of noticing. Astronomers who study public engagement with the night sky have found that people often develop a particular fondness for celestial features they have taken time to learn about, a sense of familiarity, and even affection toward objects that once seemed distant and abstract. Saturn's rings, once understood even briefly, tend to become something people actively want to see through, a telescope actively feel moved by in a way that simply knowing an object exists rarely accomplishes on its own. It may be that understanding itself is a quiet form of connection, that learning even a small amount about something vast and distant creates a kind of bridge, thin but real, between an individual small and grounded on one particular planet and something impossibly large and far away. This entire exploration, spanning ice giants and ancient astronomers' imagined skies and coral reefs responding to moonlight, has perhaps been building exactly this kind of bridge all along, connecting one quiet, resting mind to a universe of patterns repeating themselves gently across almost unimaginable distances. There is a particular comfort available in this kind of connection, one that does not require anything dramatic or definitive. It does not require Earth to have a ring. It does not require answers to every remaining question about how or why these structures form and eventually fade. It only requires a kind of quiet attention, the same attention already offered simply by listening this far into such a long, unhurried story. Consider for a moment the simple fact that light reflecting off Saturn's rings tonight, if the planet happens to be visible from wherever this is being heard, takes a little over an hour to travel the distance between that planet and this one. That light left the rings before this sentence was finished, being spoken before this thought had even fully formed, travelling quietly across an immense empty distance, arriving finally as nothing more than a faint steady point of light in a dark sky, or as data captured by careful instruments the way Cassini once captured it night after night for 13 patient years. There is something quietly beautiful in imagining that connection, however distant and indirect. A version of the same sunlight that once warmed this particular part of Earth also reaches out across the solar system, touches those wide patient rings, and reflects back outward into the dark, some small fraction of it eventually finding its way to a human eye, or a spacecraft's sensitive instrument carrying with it a kind of message that took no effort to send and asks for nothing in return beyond simply being noticed. Perhaps that is the quiet thread running through everything explored so far tonight, from Roche's careful mathematics to imagined shadows crossing invisible continents, from ancient astronomers squinting through primitive telescopes to coral reefs responding to light none of them can consciously perceive. Everything in its own way is simply continuing following its own patient rhythm, asking to be noticed only if noticing happens to feel right, existing regardless either way. That kind of existence, patient and undemanding, offers a particular kind of ease to rest inside of, especially now, as this long unhurried journey begins very gently to draw its own path towards stillness. There is a particular stretch of time somewhere between waking thought and actual sleep where the mind stops reaching forward and simply allows things to settle unfinished exactly as they are. This feels like the right place to arrive at now. Everything explored across this long unhurried night has moved through a great deal of space and an even greater stretch of time. Roche's quiet mathematics. Saturn's patient rings thinning slowly even now. A moon named Phobos spiraling gently toward its own distant future. Coral beneath the ocean timing itself to light it cannot consciously perceive. None of it asked to be solved tonight, none of it needed to be. Earth's actual sky remains exactly as it has always been, familiar, open, a single moon drifting a little further away each year, patient in its own quiet fashion. No ring stretches overhead, and perhaps none ever truly did not in any way certain enough to call fact, rather than gentle possibility. That uncertainty was never really the point. What matters more, perhaps, is simply the shape of looking upward at all, the way a person lying still in a quiet room can send their attention out past the ceiling, past the atmosphere, past the moon itself, toward rings that may or may not have ever existed, and feel somehow a little smaller and a little steadier at the same time. Saturn continues turning, somewhere out there right now, rings catching whatever sunlight happens to reach them, some of that light already falling gently, invisibly toward the instruments built to notice it. It does not need anyone watching to continue. It simply continues the way most things in this universe simply continue without asking for witness or approval. The body too continues its own quiet turning. Breath in, breath out. A little slower now than at the start of this. A little heavier, perhaps somewhere behind the eyes. There is nothing left to explain. Only the sky dark and plain and endlessly patient exactly the way it has always been. Only breath slower now. Only stillness settling in soft as dust. Only the quiet dark holding everything gently the way it always has. Rest now.